Right, so nama saya Nazrin, macam saya beritahu tadi. Okay. So ni reference book, okay. Yang saya bagi tadi tu adalah ini ya. The first one, Digital System and Testable Design. Right. Selain daripada buku tu, boleh juga refer buku lain lah. Macam CMOS VLSI Design ataupun buku Digital System Testing and Testable Design. So buku, tiga buku ni lah yang saya nampak related lah dengan course yang kamu ambil. Right. So sekarang sebenarnya week 4 lah. Kalau tak silap saya lah. Kan? Week 4 lah kan?
Oh, week 4.
Okay. So saya kena cover HDL for design and test. Maksudnya kita kena explore sikit lah HDL language. To be specific, Verilog lah. Okay. And then how do we use the Verilog HDL for design and test? Because of this subject, design for testability, kita akan fokus kepada lebih kepada test lah, okay? Sebab dia lebih kepada testability. Okay, element of design mungkin saya tak tanya lah dalam exam ataupun dalam assessment, right? And then week 5, week 6, kalau ikut plan tu kita cover fault modeling and simulation. So, maksudnya kita ada 2 minggu lah untuk cover HDL for design and test. Okay, minggu ni dengan minggu depan. Okay, and then kita cover sampai minggu ke-6 lah, fault modeling and simulation. Okay, the rest akan di cover by Dr. Azizi lah, minggu ke-7 onward. Okay. Ini adalah cost assessment metric. We have 3 COs. So saya akan involve dekat sini. Okay, and then assignment. Right. Kalau ada soalan exam mungkin gantung pada koordinator lah, Dr. Azizi ya. So kita akan buat assignment lah. Assignment ni kalau ikut set ini group lah, berkumpulan. Tapi nanti mungkin saya akan pecahkan lah. Okay. Satu kumpulan tu task yang lain-lain. Okay, contribution is 10%, okay, for the assignment number 1. Okay. Right. So I think this one Dr. Aziz dah cover. Okay. Saya mungkin buat sedikit review lah. Ini akronim yang biasa terlibat lah dalam course ni lah. Okay. ATE, Automatic Test Equipment. So built-in self-test, BIS, computer aided design, I think you all are familiar with that. And then circuit under test, CUT, device or design under test, DUT, hardware, description language ni saya dah mention tadi, JTAG. PLI ini penting juga, procedural language interface. Ini untuk mode SIM, kalau biasa guna mungkin boleh explore lah on PLI, kita boleh interface dengan C code dan sebagainya untuk buat test. And then the last one, test access port, TAP. Ini antara akronim yang mungkin kita akan jumpa. Okay, sebab subjek ni pun DFT. So testing ni kita tak boleh lari daripada test lah. Okay. Right. Mungkin saya boleh sikit lah. So testing is actually the most important part lah in this course. Okay. So test can be done in various level lah sebenarnya. Pelbagai level-level yang kita nak kena test tu. Okay. Sebelum itu mungkin kita terfikir kenapa kita perlu test. Kenapa kita tak buat terus kan. Nak duk test apa kan, buat design and then design chip, fabricate chip and then kita send to the customer. So that's actually mungkin kita terfikirlah kenapa kita perlu test. Okay. Basically test is actually to make sure our product, final product atau end product kita tu, for example kita nak buat chip kan. Kita nak make sure chip kita tu free from any errors ataupun bugs, okay, or free from any defect. Itu sebut bugs or errors ni normally dekat front end level lah, maksudnya at the design stage. Okay, so kalau apa orang panggil defect ni biasanya dia melibatkan bila dah menjadi chip lah, menjadi produk. So test ni penting because if we can trace the error or fault or apa lagi yang seangkatan dengannya, bugs, error dan sebagainya lah on our design side, maybe at the very early stage, and then we can save a lot of money lah. Maksudnya kita nak design something, kita tak test sampai kita have the product, and then baru kita tahu produk tu problem, baru kita nak back to the early stage. So that's actually wasting time and also money as well. Okay, and that's why we need to have a testing mechanism to make sure that our design is free from any errors or bugs lah. Okay, so kita kalau untuk HDL ni ataupun design awal ni, front end design ni, normally is earlier than the logic verification lah. We have behavioral or functionality verification lah. Sekejap lagi saya tunjuk. And we have also logic verification, silicon debug, and manufacturing test. So manufacturing test ni normally test yang kita buat at the end of the stage lah, yang ujungnya. Okay, apa yang saya nak mention di sini, kita ada banyak level of test lah. Okay, untuk buat test tu normally kita kena modelkan fault, okay, ataupun fault ni kita panggil apa? Benda yang kita tak mahu lah, tapi kita kena modelkan dia supaya kita boleh test our product. To test our product, contohlah kita ada produk yang besar, yang big product lah. So is that necessary to test all the possibilities on the product? For example, you have for paling basic kita ada ini AND gate, for example, AND gate with 5 input, for example. Okay, we have input A, input B, C, D, and then E, for example. Ini example je lah, and then F is the output. So in terms of testing, kita ada 5 input. Okay, since you all dah belajar Verilog, HDL, and then you all also dah have some background on authors and model sim, so I'll go straight away lah. So this is actually your mungkin saya boleh color yang lain. This is your DUT. Okay, design under test, ataupun tadi kita bagi description tadi kan. Okay, device under test or design under test, and then we have a test bench, maybe different color on this side. Maksudnya kita bagi test bench kat dia, kita bagi input, and then we monitor at the output side. So that's actually the test bench lah. Okay. So this is our test bench, and this is our output. Okay. So we have ada 5, contoh ni 1 bit lah, paling basic kita ada 1 bit each. So maksudnya kita ada we have 2 to the power of 5 possibilities. Okay, sebab apa 2 to the power of 5? Siapa boleh beritahu?
2 kuasa N.
Sebab kita ada 5 input kan, maksudnya kita ada 32 possibilities, 32 possibilities of input. So when we have 32 possibilities of input, which means that if you represent this in digital, in binary representation, you have 0, 0, 0, 0, 0. So ini adalah decimal 0 kan, until actually 31. So if you not clear, please stop me. So which is 1, 1, 1, 1, 1. Okay, and this is in binary. This is in binary. Binary. And this is in decimal. Okay. Decimal. Alright. So we have 32 possibilities of input yang kita perlu test. So just imagine if you have a bigger system that you need to test. So how much is the complexity? So maksudnya kita perlu ada a model, okay, a model to test, not necessarily to test all the input from decimal 0 until 31. So maybe we test certain input only, right? So that's why we need a model. And therefore, we need to explore how do we model a file. Okay, so that's actually the idea, right? Okay, and then we also will learn about controllability and observability. I think this one later on. Okay, and then DFT itself, scan and also BIS, okay, and also boundary scan. So yang kita akan cover sebenarnya lebih kepada yang this front lah, okay, fault model and also testing. Okay, yang lainnya mungkin Dr. Azizi akan cover. Okay, everyone clear on this one? Okay, Hazman, baru masuk ah. Boleh
baru masuk tu.
Bagi kat saya email, saya nak share draft lagi. Okay. Nanti share dekat test, dekat chat box. Okay.
Boleh tu.
Okay. Dah ada software model sim kan?
Saya tak ada lagi tu.
Tak ada. Okay, nanti tengok dekat directory tu and then install ke komputer. Azman pernah belajar tak HDL?
Ada BHD ada.
Pernah no? Dulu dekat mana belajar kat mana?
Unimap. Photonic.
Alright. Okay. Okay lah. Alright. And this is actually the detailed explanation lah, right? Kalau you baca di sini, if you can read here, so testing is one of the most expensive part of the chip. This is just a revision lah. Okay. So logic verification account for more than 50% of design effort. Okay, we try to actually reduce this task on the time investment and also effort investment for verification. So debug time after fabrication has enormous opportunity for maksudnya so after we fabricate, so normally we try to reduce before we fabricate, we try to reduce or minimize the error, and then if possible we make the error 0, so that when we have the final product, means that we have the final product after fabrication, we will save the money and then we also save the time and also the effort, right? The three parameters is very important in the DFT. So time, effort and also cost. Okay, sebab apa saya kata begitu? Sebab you have actually opportunity to settle or to identify the error or the bugs at the early stage of the design. Okay, so don't need to wait until your device successfully fabricated, but at the end it's turned to very low yield. Yield ni maksudnya dia punya kita punya ni lah, output atau produk kita tu rendah lah, yang okay berbanding dengan yang defect, right? And then another thing is actually the name of the company lah, ataupun kita panggil reputation lah, okay, reputation. So shipping defect part, okay, can sink the company. Okay, maksudnya if you don't test the product and then you do shipping to your customer, your end customer, and then you will need to modify beli lah, ataupun kena kita panggil call back lah benda tu and then do rectification. So that's actually berkait dengan cost, time, effort and also reputation of the company. Right? So if you remember in our experience in our world today, for example, kalau you beli setengah kereta kan, ada setengah company yang call balik model tertentu disebabkan defect kat satu-satu part. Itu salah satu contoh lah. Okay, saya tak boleh mention kat sini company mana kan. So maksudnya that's example of defect yang mungkin kita overlook lah, because we are human, we overlook, but we can minimize the what we call the potentiality having defective parts. Right, so Intel FDIV ini contoh yang lama lah, 1994 ni dulu. Okay, dia ada logic error. which can be traced at the very early stage lah of the design flow tu. Tapi dia tak, mungkin dia overload ataupun ada isu di sebaliknya, and then dia dah ship 1 juta, 1 million unit ship. Okay. And then what happened after that? And then they have to recall back the product, and then it costs about 450 million. So banyaklah cost kan. Kalau dia tak call balik, dia ada customer yang dia perlu. You need to entertain the customer and make sure the reputation is okay for the future. Okay, and then they need to recall back. So that's actually the cost of they need to pay lah. Okay, so that's actually the importance of having testing. Okay, so maybe if I ask you on elaboration of importance of testing, then you can use this as an example lah, or other type of example lah as well. Okay, ini contoh dia. Okay, so we go to logic verification. Okay, so normally logic verification we perform at the HDL level. Okay, saya rasa mungkin saya pergi straight ke sini dulu untuk nampak lah. Okay, ini saya rasa Dr. Azizi dah cover. Ini contoh-contoh manufacturing failure lah. Means that when we fabricate, and then we have different type of possibility of having a failures. Okay, failure dia kat sini. Okay, yang selalunya kita nampak adalah apa ni, start at atau short ataupun open defect. Macam ni, open defect, okay, ataupun open contact, open at contact and so on. Okay. Alright, so saya tunjuk yang ni dulu. We have the ni. Kalau you tengok dalam textbook, the explanation is detail lah. Right, mungkin saya zoom kat sini. Zoom here. Okay. Ini adalah yang mungkin important lah untuk nampak overview of the overall. Okay. Overall testing, design and test. Alright. Okay, saya bagi peluang untuk baca dulu, kita tengok dulu. Identify dia punya stage ya. Sementara tu Hazman minta share email dekat chat box. Share email, saya nak share drive untuk kamu. Alright, okay. If you can see here, kalau kamu tengok di sini, kita ada banyak stage lah, okay, of design. Beginning from our design dekat sini, okay, RTL synthesis, physical layout, and finally chip manufacturing, and the very end one is actually customer. Ini adalah flow yang mungkin kita dah biasa lah, you all familiar with this flow, okay, alright. So design, kalau digital design, normally we have this flow lah, RTL synthesis, okay, and then we have physical layout. So at any of this stage, okay, either RTL, synthesis, physical, or chip manufacturing, we can test our design lah to make sure that it's free from any failure. Okay. So for example, kalau you tengok sini, we have the next column ni, column yang tengah ni, number 2 ni. So kita nampak ini adalah coding, Verilog code, okay, to represent our design. Right, behavioral modeling of our design. Okay, so in the terms of testing, okay, or simulation, we can do it at RTL or HDL simulation. Maksudnya kita boleh identify any error at the functionality level lah. Okay, if you tengok di sini, the RTL simulation, okay, is taking for functionality of the design. So ini adalah benda term yang penting lah. Maksudnya we check the functionality of our design. Right? So this is actually the very early stage of our testing lah. Maksudnya you boleh test at the early stage to avoid the issue on problem with the product lah, okay, end product. So the flow tu masih jauh lah, okay. If you can trace early, means that okay, you save a lot of time, money and so on lah, effort dan sebagainya. Okay. The testing of the design here is primarily functional. Okay, maksudnya kita test function dia. Contoh macam saya tunjuk tadi, we have 5 input and gate. This is very basic lah. Saya buat sebagai yang mudah lah. 5 input and gate. Okay, so we test whether it is function as an AND gate or not. So we have the truth table. Okay, so A, B, C, D, and E. So these are the input, and then you check the output F. Okay, you test if the input lah. Okay, using the value A, B, C, D, E, then you get the F. So truth table for AND gate. So if all 1, okay, you get F equal to 1. If any of these 0, okay, if any of the input 0, you akan dapat 0. So that's actually the truth table, right? Okay. So it means that you make sure that you have the waveform that support the same as the expected output lah. Expected output is from the truth table. So when you run the simulation using the test bench study, you create a test bench, and then you run the simulation, then you get the expected waveform as you compare with the test bench. So you compare with the test bench, you get the expected waveform. Means that there's functionality. In terms of functionality, your design is free from any error or from any failure or from any bugs. Okay, that's actually the first stage. Okay. So ini adalah testing yang pertama lah selalunya dibuat oleh designer. Okay. RTL level synthesis takes the behavioral description of a design as input and produce an netlist. So ini actually the step after you run the RTL simulation, you will also run the RTL synthesis. So RTL synthesis is actually a process of transferring your coding, your code ni, RTL code kita panggil, ataupun dipanggil sini RTL level language, to the equivalent hardware or equivalent electronic hardware lah. Okay. For example, dalam case ni, our example, equivalent AND gate. Okay, 5 input AND gate, for example. So we get the equivalent 5 input AND gate after we perform the synthesis. Okay, synthesis ni tak boleh dibuat menggunakan model SIM lah. Kita buat gunakan Quartus. Kita boleh gunakan Quartus untuk buat synthesis, ataupun kita boleh gunakan software Synopsys. Okay, alright. So when we get the equivalent hardware, we can also check, okay, whether the generated hardware itu is actually AND gate or not. For example, AND gate or not. So we can check. Okay, and then we can also do netlist ataupun post synthesis simulation. Mean that we do simulation after we get the equivalent hardware. Tadi simulation at the what we call behavioral level lah. Maksudnya kita belum generate dia punya hardware. Okay, bila you do synthesis, and then you can also test again. Okay, for at the synthesis level, at the netlist level. Sorry, at the netlist level. Okay. So netlist level tu is actually comprises of gate level lah normally, and gate, D flip-flop, and so on. So during this level, you can also test. Okay, so we test our design at different levels. So during the netlist level, maksudnya you make sure that mungkin dari segi, I think ada dah explain di sini. Okay. Testing here is done by simulating with and HDS simulation tool. Sama juga. Okay, you juga boleh menggunakan model SIM. Yang pertama tadi pun boleh guna model SIM. That's why saya suruh install lah. Boleh gunakan model SIM. Di sini pun boleh menggunakan, you can use model SIM. Model SIM is an example lah, not necessarily only one model SIM. You can use Synopsys, VCS, and other two lah as well. Alright. So this simulation phase is referred to as post synthesis. Maksudnya post tu maksudnya selepas you you perform a synthesis. You get the hardware and then you do a simulation. That's what we mean by post-synthesis simulation. So with this simulation, we are checking for, so macam yang first tadi, we don't check for delay. Kita tak check delay, kita tak check berkaitan dengan hardware. So kita check berkaitan dengan functionality only. But for this stage of simulation, we focus on delay. Delay issue, races issue, maksud if we have a signal race, maksudnya ada issue of input tu pergi kepada unit ataupun modul yang mungkin ada race condition dekat design kita tu. Then clock speed, for example, we design at higher clock speed than the system can perform. Okay, so that we'll check lah. Actually, how much is the clock speed the design can perform. Maksudnya berkaitan dengan critical path of your design. Okay. Alright, so hopefully bila saya mention critical path tu mungkin semua dah nampak lah. Okay, saya boleh tunjuk sikit. Okay. So this is let's say this is your AND gate. You sambung ke mungkin lagi satu lagi AND gate. And then lepas tu you ada lagi inverter. Dan you pergi ke mungkin another AND gate for example lah. Okay. Then you ada input di sini. Okay. So bila kita sebut critical path tu maksudnya saya pakai color yang okay. Maksudnya the delay between this gate, the first gate, entering the second gate, and also the third and also the fourth gate. So this is actually the delay. Okay. The longest delay in the path is actually kita panggil sebagai critical path. Okay. So in this case, this path lah. Okay. Right. So we need to consider this to get the F, frequency of our system, whereby F equal to 1/T, and T here is actually a part of the total T here. Right. So the shortest path is actually yang ni lah. This is mungkin saya pakai color lain. So this is actually the shortest path because we only have one logic gate here. But for the shortest path, for the longest path, actually we have one logic level, 2, okay, and then 3, and then 4. So we have 4 logic level. So bila saya sebut logic level tu maksudnya kat sini lah. Level 1, level 2, level 3, and level 4. So we have 4 logic level. Maksudnya setiap ni ada delay dia, ada total of a delay contribute to small t, and small t plus the other delays, and then you get t here, the big T here. So that's actually determine the clock frequency of your design. Okay, so if you go back here, so we identify the clock speed of our design, what we call considering all the delays in the combinational logic lah. Ni kita panggil sebagai combinational logic. Okay, combinational logic. So clock critical path is actually the longest path in the combinational logic, which is this path lah yang green path. Okay, compared to the blue one. Alright, any question? Ada soalan tak? No, huh? Alright. So this is actually kalau you go to textbook tu dalam folder yang saya bagi tu, detail explanation is there lah. Okay, you can go and read lah in more detail. Okay, ini mungkin saya cover dalam lecture untuk semua nampak lah secara overall dulu. Right. So in any of these levels, so normally we need to have test bench ataupun kita punya test program. Okay, after this saya akan tunjuk mungkin recap lah sebab I think most of you, I think all of you lah ada experience on HDL, which is good lah. Dan saya mungkin boleh straight kepada HDL ataupun dia punya test bench straight tanpa perlu kita tengok syntax of the value of HDL. Okay. Alright, so dalam buku ni juga, in this book, Navabi ni pun ada di explain berkenaan dengan HDL syntax. Okay, sekejap lagi saya tunjuk. Alright. Okay, and then the next stage, we have a physical layout. So physical layout is actually you for example OR gate okay, not gate, okay, not gate. Saya bagi yang contoh yang mudah supaya nampak. So not gate, okay, not gate is actually comprises of how many transistor? Siapa boleh beritahu? Ada berapa transistor? Recap balik. Ada berapa transistor? Okay, dua. So we have PMOS and NMOS kan? Okay. So this is a PMOS. Okay, ada bubble kat sini. And we have NMOS. Then these two combine. Okay, and this is actually the output. Ini VDD. And ini adalah ground. Okay, so ini input A, for example. Then outputnya B. So equivalent to here lah, A, B. So ni, this one is in terms of, bila saya tak comment. In terms of design abstraction, so you can see lah, so the lowest level here is actually what we call as transistor level, PMOS and NMOS, and then the higher than that is actually at gate level. Okay, we can go even higher than this at RTL level, okay, algorithm level, behavioral level, and so on. Okay, and even in at the transistor level, we can go even higher, lower than this, which is at the layout level, which is here, layout. The transistor itself, we have the polysilicon, okay, with the N type and P type material, we get the PMOS and NMOS. Okay, so during this level, okay, physical layout level ni, and then we check at the layout level. Okay, for example, tadi kita tengok dekat gate level kan. Now during this stage, we check is there any error at the physical layout. Contoh, your NOT gate tadi tu, inverter gate tu, is that actually in terms of the fabrication of the layout before you fabricate lah. This is before you fabricate. If you get the layout, physical layout, and then the system will check is there any error or violation in terms of the design rule. Bila sampai kat sini kita sebut design rule lah, ataupun dia sebut apa, DRC, design rule check. So this is another test stage. Okay, so as mentioned here, they verified post-synthesis netlist. Maksudnya we make sure that post-synthesis netlist okay first, and then is used for the layout placement and tool for generating the design layout and routing of the cell. Okay, during this step, during this stage. And that's why you can see here, nampak banyak layout di sini. Okay, so now the design is, at the back end. So dekat sini tadi ni dia macam front end. Yang saya sebut back end, front end tu ni lah. Saya guna color lain. Okay, ni actually the front lah. Okay. And then start daripada layout ni, dia dah mula floor planning, kita panggil ni floor planning, itu dia dah mula kepada back end stage of our design. Right? Saya guna color lain, lagi menarik lagi. Okay, maybe this color. Okay, so this is actually the equivalent layout. So during the layout level, we can also test our design. Okay, so what we call as di sini sebagai layout simulation or detailed layout simulation. Okay, for model sim we cannot use model sim untuk do layout simulation. We stop until delay saja. Okay, untuk do layout simulation, this can be done using synopsis. Okay, synopsis, design compiler. Okay, design compiler kita boleh check dia punya layout. For those who dah ambil subjek VLSI design kat, I think kat Unimed ada subjek VLSI design, saya juga mengajar tu. You dah boleh explore lah benda. Okay, mungkin dah ada experience. Okay, alright. Tapi I think electronic student pun. Okay, so the simulation here verifies wire length. Maksudnya more on the what we call design rule check lah. Okay, DRC. This wire length, wire width, transistor size, layout placement flaws that can be introduced from the netlist to the layout. So from the netlist tadi ni, okay, to the layout ni, so there will be issues lah that normally happen. And then how to rectify this? Normally we do layout simulation, or dipanggil sebagai detail layout simulation. Okay, that is another testing method. Okay. And then once everything is finalized and we get the what we call as GDS file, okay, GDS file, and then baru you boleh manufacture, okay, ataupun fabricate lah, kita panggil fabricate lah, senang sebut bahasanya fabricate. Okay, so test the circuit and the test. So this is what we call CUT tu, okay, against manufacturing defects, and from at this level kita dah panggil defect. Kita dah tak panggil bugs, so kita dah tak panggil, we not call as bugs, we not call as failure or whatever, we call as defect. Okay, defect. So the defect are broken wires. Ni contoh lah. Okay. Okay. Okay, no? Sekejap, no? Okay, so okay, broken wires, short wires, open resistive wires, and so on, including the transistor defect and other physical problems. So means that kalau kita tengok di sini, if you can see here, the errors tu, even we try to settle at the very beginning of our design, we still need to check at the every stage of the design, okay, of the process, because for example, our design kat RTL semua okay, kita check our simulation, the design is function as expected, and gate function as and gate as expected. When we go to the netlist, it function as expected, but we have issues of delay, for example. So that's another thing that we need to make sure in our design. Kita kena test. Okay? Tak semestinya test yang pertama, simulation is success, kita stop lah. So kita kena do the other test and then the following test until the after fabrication. Okay, because when we do the test at very different level, actually we will reduce the tendency of having lots of defect lah bila kita dah cuba settle dari awal. Okay, kita tak nak defect tu because of the functionality. Kita nak defect tu mungkin kita boleh minimizekan defect tu. Okay, that's actually the purpose of testing lah. And then we make sure to improve the yield. Okay, yield ni maksudnya kita punya chip tu dalam banyak yang kita produce tu majority-nya okay. Majority okay compared to what we call defect. Okay, alright. Any question? Ada soalan tak? Ada? Faham tak?
InsyaAllah tak ada.
Okay, good. Alright, so here ada explanation. We have explanation on dia panggil sebagai post manufacturing test. So post manufacturing test ni maksudnya after you fabricate, then we test again. Kalau you pasang tadi adalah di atas slide tadi tu ada sebenarnya device yang kita gunakan, contoh ATE dan so on. Okay. Unlike the other steps, the testing is done on the model of the design. Okay, maksudnya step-step yang sebelum ni kita test at the model of design which is using simulation. Okay, testing in the last step is done in physical part. Maksudnya kita test on the chip tu, contohnya chip tu dah ada fabricate dan kita test kat chip tu, at physical. So in this testing, we are testing the circuit. Itu sebab tu kita panggil CUT, circuit and the test. Okay, kita dah tak panggil DUT lah, kita panggil CUT, we call as CUT. against manufacturing defect. So the defects are broken wires, ni macam tadi lah, and so on. Right? If no question, maybe we saya boleh tunjuk contoh-contoh defect tadi lah. Ini mungkin revision aku nak. Ini. Okay. Ini example of manufacturing defect or failures. Ini maksudnya after we fabricate and then we check. Okay. Ini contoh macam bridging. Ini bridging ni adalah short lah. Short antara metal 5 film particle. Okay, dia short di sini. Bila dia short di sini, automatic dia tak boleh function as expected. Contoh macam ni lah, senang saya tunjuk. Ini adalah back pada AND gate tadi. Okay, we have 5 key tu kan. Tiba-tiba mungkin ini short. Bila ini short, habislah. You punya F ni, you cannot get the expected F. Macam itulah. Tapi during you perform simulation, okay, you get F expected. Tetapi bila went to fabrication, you have the short here, bridging here. Short ataupun bridging lah dia panggil. Okay, and then you get the defect. So the defect here is not because of the front end design, but because of the back end part lah of the design, which is maybe during the fabrication lah. Same as this open defect. Okay, this defect may not happen during the early stage of the design, but it happened during manufacturing, and that's why we call as manufacturing. Macam-macam lagi lah, lots lah. You can read in detail lah in the textbook. Okay, okay, same as this one. Okay, this is example of the device or the what we call the machine lah. Ini kita panggil machine pun boleh juga. Okay, to test the chip. Okay, so even dust sabuk yang kecil pun boleh merosakkan chip. Okay, not necessarily benda yang besar. That's why fabrication room ataupun kita panggil clean room tu, there are standard inside the clean room to make sure that the room is free from particle lah yang boleh merosakkan chip. Okay. So in any of the cases, normally yield tu, we cannot make it 100%. That's actually normal lah. Okay, due to various factors. Normally kita fabricate, okay, our chip in our die. Okay, this is your wafer. Okay, and a lots of die here. Dalam banyak-banyak die tu mesti ada defect. Okay, so design AND gate kamu mungkin dalam ni. Okay, dalam die ni kita panggil die. So maybe some defect masih ada di sini lah, kat mana-mana di sini, and then yield cannot get 100%. Okay, so manufacturing tester ni memang expensive lah. Okay, so normally kita maksimumkan test tu at the early stage, okay, which is kalau you tengok dekat sini, somewhere dekat sini lah kita cuba sebelum fabrication, before fabrication. So that when we get fabricated chip, it's free from any manufacturing defect. Okay. So we have silicon debug and so on. Okay. Okay, saya dah cover lah slide number. Ini fault model yang saya mention tadi. Okay. To simplify defect that we are trying to test for, we develop a fault model. Okay. So normally kita tak perlu test semua lah. Okay, for example tadi yang 5 input AND gate tadi tu, we not necessarily give all the 32 combination of input. So maybe we look at the corner, maksudnya yang important. So one of the method people use, they use fault model. Okay. Fault model that we use is only a model to simplify analysis. So nampak tak? Simplify testing ataupun analysis lah. We're not going to test at all the input lah. Satu, time. Kedua, dia punya what we call as the capability of the processor of the computer. So if we test a lot of input, computer akan jadi takes a lot of time lah, mungkin days, mungkin weeks to hours, and mungkin days to settle or to complete the testing. And that's why we need to have model. Okay, fault model to test certain input only, but the model covers all the possibilities of failure. Okay, right, for finding better test vector and evaluating them. Okay, based on this model, we define fault coverage. Ini pun penting, nanti kita akan cover in our week, either week 5 or week 6 lah. What is fault coverage, what is fault model, and then how do we model fault, and so on. Okay, and as percentage of fault that have been detected for given test vector, fault coverage determine the efficiency of the number. Okay, don't worry about this one, we will cover later. Okay, you boleh baca juga lah dalam buku tu. Okay, oh saya lupa add ni tadi. Saya add to share folder. Any question tentang tu? Kalau tak ada, kalau tak ada, saya proceed ke next slide. Okay, saya share sekali lagi link untuk Azman tengok. Okay. Alright. So, kalau kita pergi ke folder tu. Alright, di sini kita tengok ada e-book. Okay, mungkin saya repeat balik. E-book yang berkaitan dengan lecture saya tadi. Jadi tengok sini ada detail lah. We have detail inside e-book. Okay, this book is actually from the library. So, the library subscribe lah. Here nampak tak? We background is for design and test, and then about the fault and fault defect modeling and fault simulation. Yeah. So if you go detail, you can see lah ada dia punya discussion that we have done tadi tu macam ni. Yeah. Then discussion on, I think flow tadi pun ada. Somewhere kat tengah, you can read on your own. Okay. Okay. Ini adalah dalam you punya textbook, page number 2. Okay. Alright. So mungkin saya tunjuk terus test bench lah. Okay. Kalau yang satu lagi tu, ini adalah ada dalam shared folder. Mungkin saya buka shared folder. The shared folder. Tadi kita cover yang ini. Okay, ini Berlock modeling concept. Okay, ini just revision lah. I think you all dah belajar subjek ni. Okay. Okay, ini satu. The one which is, I think this. Okay. So saya suka nak tunjuk yang ni dulu, yang test bench ni. Okay, sebabnya, ya. Okay. So this is actually how do we test lah actually design. So kalau you pergi balik yang lecture note tadi. Sekejap, saya cari balik tadi. Okay. Okay. Boleh tengok flow ni. Okay. So we will cover using HDL on testing the site. Actually, this part lah. Okay, this part. This part. Okay, so we do RTL simulation and also we can do the post synthesis simulation lah. So, but to get the idea to understand the concept. RTL simulation or if there's simulation at this level number 1 also is enough. The rest mungkin you cover with theory lah, right? So inilah sebenarnya cara kita test. Kita insert our design here, okay, DUT, and then we have input or stimulus into our design, okay, and then we monitor the output. So that's actually the fundamental of testing lah at the first stage of the design. Yang ni, okay. Okay, kalau you tengok balik di sini, DUT is actually our design written in Verilog HDL, and testbench also another Verilog HDL file, and we can also write not only using Verilog, but we can also use other type of languages like C language and so on. Okay. Okay, before kita proceed itu, mungkin saya tunjuk sikit lah. Okay, so Verilog modeling concept ni, okay, we can, yeah. We have this is just recap. We have a module, okay, and then we name the module, and then we close the design by having the end module keyword here. Okay, so the rest inside this one is really we have the port declaration dan juga the behavioral model of our design. Normally we have always lah, we use always and also assign statement in our design or DUT. And then initial ni kita gunakan untuk we use for testbench. Initial and always. And sometimes assign. Okay. But initial cannot be used in our design lah. It cannot be used in DUT. But this is in the testbench. Ini adalah yang penting atau yang important lah. Okay, we can also instantiate other lower module lah. Okay. Okay, for example, okay, tunjuk. Oh, ada. Example, mungkin boleh tengok ini paling basic lah. Okay, this is AND gate. Kalau you ingat tadi, we have tengok ni, ini AND gate yang paling mudah. Kalau you ingat tadi AND gate 5 input kan. So ini adalah AND gate 2 input. So input A, and then input B, and then output Y. Okay. And then how do we represent this in Verilog? So we have module declaration and end module, okay, module keyword and end module, and we declare the input port. So A and B is the input, okay. Y is the output. We put here Y, okay. And red Y is actually because we use always block, and any left hand side element to mesti register data type. That's why we have Y, okay. Red Y. And then A and B ini adalah standard lah. This is a standard. Okay, standard to represent the AND gate. So this gives us equivalent hardware, which is 2 input AND gate. Alright. Ini adalah kita punya DUT ataupun design under test. Okay, so if we go back to simulation, so let's say this is our AND gate with the 2 input. Okay, saya gunakan satu lagi. Okay. So this is our AND gate. Okay, and then input A, input B, and then Y, for example. Okay, this is our DUT. And then this is our test bench. That's the design. Saya punya tangan tak berapa ni. Okay. This is much better. Good. Okay. This is your test bench. And this is your DUT. So DUT mungkin I use different color. This is your DUT. Then we connect the DUT with a test bench. This is input A, B. So just to differentiate lah, this is small letter and then this capital letter, and this Y. This is actually the concept ataupun the idea of a test bench lah. If you go back to this one, same as this one lah. Okay, so AND gate is inside this DUT, and then you supply the input here, and then you monitor the output here. So if you go here, same like this one. Okay, I think you all familiar with this. Any question before we proceed? No, huh? Okay, no. If no, I write the test bench lah. So we give a test bench, write the test bench. You give any name lah. For example, your test bench N, and then test. Then you create the I/O port. Okay, test bench has no port. Sorry. So you just open and close. And you start define the input and output register and also wire. So normally input become register lah. Okay, right? A, comma, sorry, A, comma, B, comma, all the inputs covered already, and then another side which is the output become wire because we going to monitor. So input A and B at the design and the test to become register because we're going to supply the input A and B. Kita nak bagi input A and B, dia mesti register data type, and then wire ni is actually because kita nak monitor the output. So wire Y. Okay, ini semicolon, ini pun semicolon. Okay, and then we call the DUT here under our test bench. So for example, the DUT name here is actually for example N2, for example. Okay, we call N2, and then DUT. This is actually any name lah. Okay, and then you instantiate the module. So remember, we go back here. So it's actually the test bench. This is actually the template lah for test bench. So DUT instantiation we doing just now, and then stimuli signal declaration, your input. Okay, normally input become register, output become wire data type. Okay, and we instantiate, and after that we will give the input. Instantiate first. So instantiate. So the DUT is actually A. So dot A, open bracket, close bracket with A of your test bench. Open. You can bring up a bit. Okay. And then dot B, and connect with B of the test bench, comma, and then dot Y of the DUT, connect with Y of the test bench. So this is actually how you do the interconnection or instantiation. And after that, you give the input stimulus. Okay, this is command lah. Okay, command we put forward slash, 2 forward slash is actually command. And this is instantiation. Okay, DUT instantiation. Right. And then we give input to A and B. So this is actually the thing that we mentioned just now. Saya discuss tadi kan. Contoh, kita ada semua 5 input. Do we need to supply all the input? So normally we don't supply all the input lah. We just focus on the important part of the input. For example, untuk AND gate, the most important part is actually if you supply all 1, is that give 1 or not? Okay, that's actually one of the testing. And if we give 0 in any of the input combination, is that give 0 or not? So that's actually the corner ataupun the important part that we interested on to check whether escape function has ended or not. If you go back here, let's say we give input. So we should start with initial. Initial begin. Okay, initial begin, and then you give input. So A equal to 1. Okay, and then B equal to 0, for example. And then we delay this. Oh, sorry, this one. Yeah, okay, and then we delay for 10 time minute, for example, and then we give another input. Okay, A equal to 1, B equal to 1, for example. So this will check possibilities of the some other. If you give all 1, you get back 1 ataupun tak. And if we give any of the input 0, you get back 1. Okay, kita boleh test sebenarnya 2 prosedur lah, 2 to the power of 2. 2 to the power of 2 combination, which is equal to 4 lah. Combination which is 0, 0, 0, 1, 1, 0, and then 1, 1. But we are interested on this part only, for example, any of this. Okay. So we check, we put here. Okay. So A equal to 0, for example, B equal to 1. And we give the input to the design and check the output. And then end module. Ini adalah contoh lah cara kita nak test our design, functionality of the design. So when we run in our model sim, but we have to make sure that we have the DUT first lah. So the DUT, write another code. Okay, sama macam yang tadi tu. Kita tulis balik lah code. Module, N2, for example, sebab kita mention sebagai sini N2, so N2 lah. N2, and then you punya IO input A, comma B, and then output F, fine. Sorry, Y. Output Y, and then always add A, comma B, Y to A and B, then semicolon, and module. Okay, so this is our design. Okay, this is our DUT. Maybe we write a comment. Design. Okay, for design. Ini adalah kita punya test pen. So when we run in the model C, we should be able to see the waveform. Okay. See the waveform. And then we verify lah the waveform, whether the waveform is as expected or not. So for example, in this one, the kita panggil truth table for this is actually ini kita punya A, this is B, and this is Y. Okay. So 0, 0, 0, and then 1. When you run the simulation, you get is equal to 1, so it means that your design is actually free from any design error lah at this stage. Okay, so which is functionality lah. We modify, we check in terms of the functionality. So we are at this level. Okay, so I give you this task. Okay, you all I think dah ada access to this. Okay, if you go to share folder ni, kode ni pun ada kat sini. Bila you buka, memang saya tulis tu ada di sini. Dia tak update ke? Okey, dah update. Okay, you boleh try coding ni dalam modus ni. Alright. Any question before we end? I think saya akan stop our lecture. Okay, saya stop recording first.